right, let's take a look at Chapter 3, Section 3.2, the truth tables. State the truth tables for the 5 fundamental connectives. Compute truth tables for compound statements. Determine when statements are logically equivalent. State and apply De Morgan's law. We want to know if a pair of similar statements, such as not the quantity P and Q, and not P and not Q, mean the same thing. Remember, in the slides, the colon is the negation. We use truth tables to determine when compound statements are true and when they are false, and whether a pair of statements have the same meaning. If P is true, then not P is false. If P is false, then not P is true. All possible truth values for the statement P are listed in the first column. P is either true or false, and the logical values for not P are listed in the second column. Determine whether each statement is true or false, and then state its negation. Notice how the negation of each statement has the opposite truth value of the original statement. The Dallas Cowboys are a well-known football team. Mexico is a prosperous country in Asia. The Dallas Cowboys are a well-known football team. This is true. Therefore, its negation, the Dallas Cowboys are not a well-known football team, is false. Mexico is a prosperous country in Asia. This is false. So Mexico is not a prosperous country in Asia is true. A conjunction is true only when both of its components are true. All possible ways that P and Q can be true or false are listed in the first 2 columns. When P is true, Q can either be true or false. So we have TT and TF. And when P is false, Q can still only either be true or false. So we have FT, FF. So the conventional starting of every truth table is PQ column listed as P, T, T, F, F, listed as Q, T, F, T, F. Now the conjunction P and Q is only true when both components P and Q are true, which is the first line. Otherwise, false. So the truth table result is TF, F, F, the last column. Determine whether each statement is true or false. J.K. Rowling is a well-known writer, and U2 is a famous rock band. Shaquille O'Neal played first base for the Atlanta Braves, and he refuses to do TV commercials. When you are 50 years old, you will be a billionaire, and Maine is larger than California. For statement A, J.K. Rowling is a well-known writer, and U2 is a famous rock band. P is the statement J.K. Rowling is a well-known writer. Q is the statement U2 is a famous rock band. We list all possible ways that P and Q can be true or false in the first 2 columns. In the third column, we list the truth table result for P and Q. P and Q is only true when both components are true. So the first line is true and the rest are false. Our truth table result is TFFF, the last column. In this case, both components of the conjunction are true, so by line 1 of the table, the entire statement is true. Shaquille O'Neal played first base for the Atlanta Braves, and he refuses to do TV commercials. Again, Shaquille O'Neal played first base for the Atlanta Braves is P. He refuses to do TV commercials is Q. Because both components statements are false. Using the fourth line of the table, we see that this statement is false. When you are 50 years old, you will be a billionaire, and Maine is larger than California. Of course, we don't know if you'll be a billionaire by 50, so P is either true or false, but we don't know which. However, we do know that Maine is not larger than California. Therefore, we are dealing with either line 2 or line 4 of the table. In either case, the statement is false. All possible ways that P and Q can be true and false are listed in the first two columns. Our conjunction is listed in the last column. Our truth table results here isn't the last column. It's these two potential rows, which are both false in the last column. A disjunction is false only when both P and Q are false. So a conjunction was true when both components were true. A disjunction is false when both components are false. The first two rows are the conventional ways of writing the truth table, where we list all possible ways that P and Q can be true and false. By convention, we list P first, T, T, F, F, and by convention, we list Q second, T, F, T, F. P or Q is only false when both components are false, which is line 4. The book is pointing out in line 1 the inclusive or. The inclusive or is unusual to the way we think about the word or, but we do use it in our language. If you tested into this class by your ACT score, or you tested into this class through your AccuPlacer score, had you taken both and they both said you belonged in this class, both true, it would have meant you were really, really meant for this class, right? So both being true does not negate an or. So that idea is called an inclusive or. Consider the following help wanted ad. Management trainee wanted. Applicant must have 4-year degree in accounting or 3 years of experience working in a financial institution. Which applicants should be considered for the position if we interpret or according to the figure? A. Aya has a 4-year degree in accounting and has worked 2 years for a loan. Heidi has studied accounting in college but did not graduate and has worked for 5 years selling electronics. And Monty earned a 4-year degree in accounting and has 5 years of experience working for a credit card company. Aya's background corresponds to line 2 of the table, so she should be considered for the job. Because in line 2, we are left with true in the last column of line 2. Heidi's credentials are reflected in line 4 of the table, so she's not qualified. Monty's background corresponds to line 1 of the table, so he should be considered. Because of the similar structures, there are parallels that occur in logic and set theory. In set theory, we have the intersection. The symbol was pointing downward opening. And in logic, we have the same idea of the and, which is a downward facing V shape. We call the caret, right? In set theory, union was an upward facing Union was an upward facing U, whereas in logic, it's a sharper symbol like a V, and they both still stand for the concept of or. In set theory, the concept of not was represented with a complement, and in particular, the not we're looking at is the complement and not the difference, right? Because there are two concepts of not in set theory. And in logic, we have the tilde. If then statement, which is represented with the arrow, is in set theory the concept of a subset because one side depends on the other for its existence. Often, if a result is true for set theory, then a similar result also holds for logic and vice versa. We use truth tables to find logic values of complex statements. Compute a truth table for a statement of the form not P and Q or P and Q. Solution. So we can solve this problem easily by breaking it into three simpler problems. Step 1, calculate the left-hand side. Step 2, calculate the right-hand side. Step 3, use the results from step 1 and step 2 to calculate the actual result of the truth table for the full statement. We will next perform each of these steps in the following table. The P and Q are by convention the way we start every truth table. T, T, F, F, T, F, T, F. We need not P so that we can complete step 1. So first we have not P, then we and not P with Q, which and is true if both components are true, which only happens on line 2 if you focus on the Q and the not P column. Step 2 is to look at the right-hand side, P and Q. If you focus on the P column and the Q column and these, we have true in both components in line 1 only. Now we look at step 1 column, step 2 column, and we OR the results. ORs are false if both components are false. If you look at columns for step 1 and step 2, both components are false on line 2 and line 4. So the truth table result for our statement is TF, TF. If P is false and Q is true, line 3 tells us that not P and Q or P and Q is true. Definition. If the final column of a truth table contains all T's, then the statement is always true. Such a statement is called a tautology. How many lines should your truth table have? If the statement has K variables, then it's true. Then its truth table will have 2 to the K lines. If your statement has K variables, then its truth table will have 2 to the K lines. Two statements are logically equivalent if they have the same variables, and when their truth tables are computed, the final columns in the table are identical. Assume that you have an entertainment book containing discount coupons for movies, restaurants, and other leisure activities. You are considering eating at either the pasta bar or the deli. Do the following two statements say the same thing? It is not true that the pasta bar accepts coupons and the deli accepts coupons. And the pasta bar does not accept coupons, or the deli does not accept coupons. If we let P be the pasta bar accepts coupons and let D represent the deli accepts coupons, then we can write A and B symbolically as not P and D versus not P or not D. If we let to decide whether these statements say the same thing, all we have to do is make two truth tables. P is comes before D because it came first in our compound statement. And by convention, the first variable has the structure TTFF, the second variable TFTF, giving us all possible outcomes of P and D. P and D as a conjunction is only true when both components are true, which is in line 1, looking at the P and D column. Now we negate the P and D column to get the truth table results of A, which is FTTT. Now, secondly, we look at the negation of P and the negation of D, keeping the structure the same as the original table. So if P is TTFF, then not P is FFTT. If D is TFTF, then not D is FTFT. Looking at the not P and not D column and ORing them, we know that the only thing that makes the OR false is if both components are false, which happens in line 1. The final result in the truth table for statement B is FTTT, which is the same. It's the same as the first statement. Because the final column shaded in red and the two truth tables are identical, the two statements are logically equivalent and therefore express the same information. If P and Q are statements, then P and Q negated is logically equivalent to not P or not Q. If P or Q, if we take P and disjoin it with Q, so we have P or Q, and we negate it, then that is logically equivalent to negating P, negating Q, and then conjoining them. Use De Morgan's law to rewrite the following statements. Those were De Morgan's law. We often say distribute the negation, flip the sign. So if we distribute the negation and flip the sign, we have the results of the De Morgan's law. Use De Morgan's law to rewrite the following statements, which is based on the instructions for filing Form 1048 with the U.S. Internal Revenue Service. It is false that you received interest from a seller finance mortgage and the buyer used the property as personal residence. It is easy to write the statement if first we represent it in symbolic form. Let R represent you received interest from a seller finance mortgage, and let B represent the buyer used the property as personal residence. This statement has the following form: not the quantity R and B. R and B negated. By De Morgan's laws, this statement is equivalent to not R or not B. We can now rewrite this in English as you did not receive interest from a seller finance mortgage, or the buyer did not use the property as a personal residence. We will construct a truth table for not P and Q or P and Q, which you saw in a previous example. Oh, let me start over. What we're doing now is the alternate method to construct a truth table. So we're going to look back at a compound statement we constructed where we broke it into 3 steps, and we're going to look at a different version for forming truth tables. Okay, and you're welcome to choose whichever is most comfortable for you. We will construct a truth table for not P and Q or P and Q, which you saw in a previous example. Recall that we constructed a table by performing the following steps. All right, so constructing the table in this alternate way is to insert the information you need right below what you write. And having less header, but sort of getting nested inside of itself. If you like this version better, that's fine. You just have to understand where your answer is. Because now the answer is not on the end, it's in the middle. But everything since P and Q, the original P, Q that we write down is our starter columns on every statement. The entire header from that point on is the statement itself. The right-hand side, we need not P, we need Q. So we write those right below where we need them. And then we have the columns beside each, right to the left and right of the conjunction. So we can join those two, seeing that they're only true on the third row. Then we have to skip over that or symbol in the middle, write down a P, write down a Q, write the information right below it, just copy the values over. Again, conjoin the P and the Q, right? So we have P and Q, the conjunction. You still have to keep track of where step 1 ends, where step 2 ends, and in the end, do a disjunction, right? Or step 1 with step 2 to get your step 3, which is your answer, but it's nested on the inside now. So highlight it, circle it, mark it, do something, write the word answer above it, point at it, do something to indicate that's your answer. Let's see. We will construct a truth table for not P or Q and not R by performing the calculations. Calculate the left-hand side, calculate the right-hand side, then do the final operation of conjunction. In this example, we're going to look at 3 variables. If you recall, if we had 3 variables, then we needed 8 lines, right? 1, 2, 3, 4, 5, 6, 7, 8 lines, half of which are true for P and false for P. For your true block for P, half of the results are T for Q, half of the results are F for Q. And then you break your F block up the same way, giving half trues and half falses to Q. And then you break your Q blocks up. So for your Q block of trues, you have TF for R. Then you have a block of falses that you split in half for R, TF. You have a block of trues, you split that in half for R, TF. You have a block of Fs, you split that in half for R for TF. So these first 3 columns are the general starting of any 3 variable. And if we had 4 variables, we would double this and have 16 rows. All right, then they list their not P, they list their Q, giving themselves side 1, or we would call that the left-hand side. Then they skip over the middle, write not R down for the result of the right-hand side. Finally, looking at step 1 and looking at step 2, we can conjoin, having the answers written FT, FF, FT, FT. somehow highlighted so that the reader knows that's your answer.